Hey everybody, today we're going to be remaking my second concatenation video on basically concatenation with multiple inputs. So I already remade the first video, you can watch that, I'll leave a link in the description to that. So let's just get started. I have an example here and that's how we're going to find our new formula. Now notice how this is only 4 inputs. I'm making the formula for k inputs, so we're going to do an example, see where it gets us, and then basically create a formula from there. So we know that this is going to be equal to, it's going to be 275208110, right? That's kind of just the definition of it. I don't care about the commas and whatever. Okay, so what we can do is we can actually separate this. So we'll have this 27 times 10 to the 6 plus 520 times 10 to the 3 plus 8 times 10 to the second power plus 10 times 10 to the 0. Okay, why did I do this? So if you watched the first video, then you should probably be able to figure out why. This is kind of what we did last time. So what I'm doing is I'm separating it out. So we have this 27 here, the 520, the 8, and 10. Basically, we have everything lined up. And then we have 10 to some power. This power, in the first video, this power was just the number of digits that this guy had. But today, we realize that this 6 does not correspond to this. The 6 actually corresponds to all of the decimal places that come after, right? So, or all of the digits basically that come after. So this is the number of digits from these guys, right? So what you may notice is that this 6, you can say, well, you take the number of digits from here, plus the number of digits from here, plus the number of digits from here. This 3 is the number of digits from here, plus the number of digits from here. So, you can really easily see that. So, obviously, there is a sum, like a big sum going on here. If we had a huge number of numbers we're concatenating, let's say we had 20 different numbers that we're concatenating, then yeah, we're going to have a large number here. And it's going to be the sum of the number of digits of these guys. So if we're adding up all of those number of digits, we're going to have to use our friend. Or, because we're using exponents and stuff, you'll see that we'll also be using the other friend. So let me actually get rid of this for now, because we'll be seeing them in a few minutes. But yeah, so what I want to do is just basically, we can actually just create the formula right now. So the concatenation, so I'm going to say A1 concatenated with A2 concatenated with A, blah blah blah, all the way to A sub n minus 1. Actually, let me use k. So A sub k minus 1 concatenated with A sub k. First off, this is a large expression, and I don't know why they're not all aligned, whatever. This is a large expression. So a great way to simplify this is to just invent a new notation. I'm going to define this to be equal to the concatenation of A sub I, where I goes from 1 to k. Just some shorthand, and it just means this guy. I don't know why I got rid of that. So we're gonna actually develop an expression here. So let me keep this. So I'm going to put it down here, so that I equals 1 to k, k of A sub I, and this is going to be equal to, well, first off, we're taking a sum. Each of these is something we're adding, so we're going to sum up all of the A sub i's, because this is A sub 1, A sub 2, A sub 3, A sub 4, so we're going to sum up all of these, and then we're going to multiply by 10 to something. But first, before we do that, I want to put the bounds on this guy. So we're actually just starting from I equals 1 to k, because if you notice, we're going to be doing A sub 1 times 10 to the whatever, plus A sub 2 plus times 10 to the whatever, and so on, right? All the way to k. So this in the exponent, I'm going to have to use some more space here. I'm going to just borrow this real estate here. Just going to just do that, right? There we go. Just a little crooked, but it's okay. Alright, so this is going to be 10 to the, well, we're going to be taking the digit sum of each of these. And remember, the digit sum formula, the formula we need to know is the floor of log of x plus 1, right? So this is important. So we're going to be taking the sum of all of these. That is a terrible sigma. Hold on. There we go. Of the floor of log of x, and again, this is base 10 plus 1, right? So let me put parentheses around this guy just so we're clear. And again, we're going from not necessarily. Actually, why did I put x? I meant a sub. Well, actually, that's what we're going to talk about. Hold on, let me hold off on that. So there are two ways you could do this. You could say, hold on. So we're going to be starting the first term that we're going to start. We're not going to actually start with this term, right? On this term, the exponent is not going to include the digit sum of this. We don't want to count these digits. We want to count the digits of everything after, right? So it's going to start at the next term. So like for this exponent, we're starting at the next term, right? And then going onwards from there. So you could say j, you could say an exponent j equals I plus 1 again to k, right? So all the way to k. So then you could say this is log of a sub j plus 1. Or you could say log of a sub I minus 1, or I plus 1, right? You don't even need to reindex it. You could just say log, like, again, keep this as I equals 1 to k, and just say this is a sub I plus 1. It's up to you. But I don't really like this formula, right? Because this is a sum inside of another sum. Fortunately, there is a nicer way to put this, right? You can, let me erase this once and for all. So what I'm going to do now is I'm going to break this up a little more. So we have this 27 here, as usual, and then I'm going to say, okay, well, previously we added up these, so 6 equals 3 plus 1 plus 2, but I'm going to say we're going to have this 10 cubed multiplied by 10 to the first times 10 squared. The reason why I broke it up this way is because 3 is the number of digits here, 1 is the number of digits here, and then 2 is the number of digits here. So in the exponent, we'd have 3 plus 1 plus 2, which is in fact 6. And because of an exponent rule, you can multiply it out like that, right? So then we'll have this 520 times 10 to the first times 10 squared. And then we have this 8 times 10 squared plus 10 times 10 to the 0, right? So this is what we have. I hope you can pretty easily see that we broke it up the way we did. So this 10 to the first times 10 squared is just equal to 10 cubed, and that comes from this being 1 digit and this being 2 digits. For this one, we just have the fact that this is 2 digits and that's it. And then here, obviously, the 10 to the 0, there are no digits that come after. So yeah, okay. So this way, you can see that another way to say this is that, again, we are going to be summing up from I equals 1 to k of a sub I, but then we're going to be multiplying by the product. We're going to be taking the product of each of these, 10 to the number of digits here, times 10 to the number of digits here, and so on. So again, we're going from j equals I plus 1 to k, or again, you could do the same thing I did here, or the same thing I talked about here. And this is going to be 10 to the floor of the log of a sub j plus 1. I personally prefer this because we don't have this sum in the exponent. I like this. I think it's a lot cleaner. And yeah, so we have the 10 to the digit sum, or not digit sum, the number of digits. And then we're multiplying each of these, and we get that. So yeah, I generalized this formula in 2 different ways. They're equivalent because, I mean, this is just that. It's easy to see if you manipulate it a little bit. But yeah, so I will be making a couple other videos on concatenation in the near future, so stay tuned for that. And that's pretty much all I have for you today. So thanks for watching, and I'll see you in the next video. Bye, guys.